اعوذ باللہ من الشیطان الرجیم بسم اللہ الرحمن الرحیم. السلام علیکم students. This is science lecture for class 8th Cambridge chapter number 13, measuring the density of an irregularly shaped solid. The density of an irregularly shaped solid such as a pebble can be found in a following way. The mass of pebble is found by placing it on a top pan balance. This is the top pan balance, which is more accurately mass measuring device, and other name is digital balance, as I already discussed in the previous lecture. Underline this top pan balance for the MCQ. As for a solid of regular shape, the volume is found by pouring water into a measuring cylinder until it is about half full. The volume of the water is read on the scale, and then the pebble is carefully lowered into the water on a thin string. This is very important, because if you are using the thick string, then the volume of string will involved in your reading, and your reading will not be more accurate. Okay, so this is very important MCQ, so underline thin string. When the pebble is completely immersed in the water, the volume of the water is read again on the scale. The volume of the pebble is found by subtracting the first reading from the second. The density of the pebble is found by dividing the mass of pebble by its volume. Now the figure 13.3, measuring the volume of a pebble. This one is measuring cylinder, and I'm going to perform the practical. Is more helpful to understand the concept of measuring the irregular shaped pebble by using the measuring cylinders.
Hi students, today I am going to study the measuring cylinder, and by using the measuring cylinder we can measure the density of irregular shape of any pebble. Okay, this one is the measuring cylinder, and the readings are mentioned on this surface in milliliters. And this is the pebble attached with the string, piece of string. Measuring cylinder, pebble, string and water. There are four things required for the measure the density of irregular shape. This is the first reading, as we can see that 85 milliliter. Okay, and just put the pebble inside the water by the help of string. Now the pebble inside of the cylinder, and the water will rise up, and the second reading will be 90 milliliter, and we can find the volume of this pebble by just taking the difference between two readings, as this is the first reading 85 milliliter, and this one the second reading 90 milliliter. Taking the difference of these two readings, we will get the volume of this pebble. Okay,
now I'm going to take a question number 6 here. The mass of pebble was 88.4 gram. The original volume of the water in the measuring cylinder was 50 centimeter cube. This is the just volume of the water before immersing the pebble in the water. After immersing the pebble in the water will rise up, okay, and that will give you another reading, and which is, and the combined volume of water and pebble was 84 centimeter cube. You can say that this is the second reading and this one is the first reading. What is the density of the rock in the pebble? This is a figure in which you can see that this is the pebble and this one is the thin string, and this one is the first reading of water without pebble, okay. And after immersing the pebble in this measuring cylinder, the water level will be raised up, okay. And after rising the water level, we can just find the volume of a pebble by subtracting both two values, here to here, and this one is the volume of the pebble. So the data, this is on the mass of pebble, 88.4 gram. The volume of pebble can be found by subtracting second reading. This one was the second reading, 84 centimeter cube, and this one was the first reading, which is 50 centimeter cube. Subtracting the both of these values, we will get 34 centimeter cube. This is the volume of pebble basically, and we will use the formula for the density is simply the ratio of mass of pebble with volume of the pebble, that is equal to the density of the pebble. Now I am going to the solution, toward the solution of this problem, and just replacing the values in this formula, we will get that density of the pebble is 88.4 gram divided by 34 centimeter cube, and just by dividing both two values we will get 2.6 gram per centimeter cube, that is the density of the pebble. Now measuring the density of a liquid. The density of a liquid is found in the following way. The measuring cylinder is put on a balance and its mass found A. The liquid is poured into the measuring cylinder and its volume measured V, okay. And the third point, the mass of measuring cylinder and the liquid it contain is found B. The mass of liquid is found by the subtracting A from B, okay. This one was the first mass and this one is the second mass, and we can find by subtracting B minus A, that is the mass of pebble. Basically these are those steps which are similar to the previous lecture as I discussed in the measuring the density of irregular shaped solid. The density of the liquid is calculated by dividing the mass of the liquid by its volume. For all the cases, density is equal to mass over volume. Mass of the cylinder without liquid, and this one is the mass of liquid with the mass of cylinder. So by subtracting to each other we will get the mass of that liquid in it. The whole scenario of measuring the density of the liquid is available in this picture 13.4, finding the mass of measuring cylinder and liquid it contains, okay. This is the digital balance, and just by using that formula, this is the mass per volume, we will be able to find the density of the liquids. So this is table 13.2, the densities of some liquids. The liquid mercury have density 13,550 kilogram per meter cube. Water at 4 degrees Celsius is 1000 kilogram per meter cube density of water. Okay, and other materials are mentioned in this table. This is the very important for MCQs. Now floating and sinking, this is another process. When a piece of wood is placed in water, the wood floats. This is due to the difference in the densities of the wood and water. From the table 13.1 and 13.2, you can see that the wood is less dense than water. When two substances such as a solid and a liquid, or a liquid and a liquid, are put together, the less dense substance floats above the denser substance. Okay, this one here in this picture, the denser substance, and this one is the less denser, and this third liquid is more lesser than both two available liquids. Okay, here in this passage the writer says that the full fat milk is less dense than watery milk. Okay, so this is the another MCQ. Full fat milk having less density as compared to watery milk. Okay, so fat rises to the top. Okay, now I'm going towards the density of gases. Air is a mixture of gases. This is the MCQ, underline please. Its density can be found in the following way. Here three steps. Okay, the mass of a round bottomed flask with its stopper, this one is the stopper. Okay, pipe and closed clip is found by placing it on a sensitive top and balance. This is very sensitive top and balance or digital balance. Okay, the flask is then attached to a vacuum pump. This flask is attached with the vacuum pump to remove all the gases available in this flask. Okay, the air is removed from the flask and the clip is closed. Okay, the mass of evacuated flask, stopper, pipe and closed clip is found by placing it back on the balance. The mass of the air in the flask is found by subtracting the second reading from the first. Same process as I already discussed in the case of pebble, in the case of liquid. The third step, the volume of the air removed is found by opening the clip under water so that water enters to replace the volume. The water is then poured into the measuring cylinder to find the volume. Okay, to find the volume of this cylinder we will use the water. Okay, so these are two questions. Question number 13 and 14 are the task at home. You can discuss with me on the Google Classroom and WhatsApp group. Okay, Thank you so very much, students. Allah Hafiz.